Hello everyone, my name is Gulin and this is Yash. So today we would like to present our hotel cancellations reductions project. And here's the agenda. So first we will start with the project overview and the value of this project. Then we will move on to the problem domains, the methodologies and the set that we use, and our performance metrics, how we do the feature engineering, modeling, and model evaluations. And lastly, we will talk about the influence and the coverage of this project. So this project starts with a question that can we find out which customers are likely to cancel their reservations and prevent that using the discount campaigns that are ML driven? And of course, in this project, the answer is yes, we can. And we did achieve that by building a classifications model that can predict which customer is likely to cancel their reservations so the hotel can act up on that. And that will help to reduce the number of cancellations and help the hotel to make more profit in the data-driven fashions. Moreover, we also found out that whether how much profit the hotel can make by using our model is also depends on whether the campaign is successful or not. So we suggest the hotel to use our model along with a qualitative customer interaction approach to reduce the number of offers that we provide to the customer that won't actually cancel the reservations, and also along with the metric on success of the campaigns to determine which campaigns are more successful than the others. And then on to the problem domains. So since the pandemic, the booking cancellations rate has been increased drastically. So it's increased from 20% in 2019 to 33% in 2022. And this high cancellations rate impacts the hotel revenues and also the opportunity of the hotel to participate in the marketing channels. So to tackle this problem, we built a machine learning classifications model to determine which customers are likely to cancel their reservations and to compare our project with the part of the ML task performance and experience. The task is to predict if a hotel customer will cancel their reservations given the reservations details. The performance is how precisely the hotel can target the customers that are likely to cancel their reservations, and about how to quantify and how precisely we will mention more about that in the performance metrics sections. And the last one is the experience, which is the historical data of the hotel reservations that our model will be learned on to improve its performance on the task. And the dataset that we use is a hotel demand dataset from Gaggles. It provides information related to the hotel reservations, such as the arrival date, number of persons, type of rooms, and also target variable, which is whether a reservation is canceled or not. So it consists of 32 columns and about 120,000 rows.
All right, thank you, Kulnit, for that. Let's talk a little more about the performance metrics that we will be judging our modeling capability on. In our specific case, we have chosen to use F2 scores as the metric of concern, specifically because when we ran some simulations, we found out that it was more important for us and more profitable for us to find out who are about to cancel and give them a discount and retain them than give a discount to people who might not be people who might churn, and the loss that we make on that is much smaller. Essentially, for us, recall was more important than precision. As you can see, recall in this case is how many do I actually recall of the actual number of people who are going to cancel. So that is very important to us. Next slide. Next, we dig into some feature engineering. We wanted to, obviously, as Kulnit specifically specified, our data set had a lot of features to work with. So we removed the features first, which were not representative of how the hotel industry client would probably look at the data. They would not have details about what happened after a person had already arrived at the hotel. So we removed those features. We imputed the missing values using techniques specified in class. Also, we looked at the multi-correlation between different feature sets, between different features using VIF scores, variance inflation factor scores. Then we did some outlier detection and removal using 1.5 times the IQR as our lower and upper bounds. We split our data set into 20% test and 80% training. We one hot encoded our categorical features and standard scaled our continuous features. And by the end, we also tried out different ablations where, let's say, for example, you have a categorical feature with multiple different types of categories, which can range up to 200. We wanted to see how much of this information do we want to retain in the sense, can we bin them into others if they're, much less in frequency? So we ran some experiments on that as well. To showcase how we actually did, we see here in this slide that we did a 5-fold grid search cross-validation where F2 score was the criteria of actually choosing a model uh, in between these cross-validations that we did on different modeling techniques. As far as the modeling techniques are concerned, we used multiple. We used 6 of them to be specific in our case, where we tested it on logistic regression, k-nearest neighbors, decision trees, random forest, XGBoost, and artificial neural networks as well. We wanted to test a host of these to maximize our chances of getting a great model. Quick caveat, in the logistic regression, we actually tested out the categorical binning strategy that I just addressed. And by the end of this ablation study, we found out that random forest gave us the best results. Moving on. Next slide. Yes. Next on, we actually try to evaluate and see if we can fine tune the model that we have selected so far. So to do that, we wanted to address the class imbalance bias that we might have in our case where, the canceled, obviously the canceled labels would be smaller in number than the non-canceled number. So we try to decrease the minority class imbalance by oversampling it using SMOTE. We found out that it boosted our F2 score by a large margin, which was 0.847 now on the train validation set. When we tested this model on our test data set that we had initially kept aside as 20%, we found out that these are the metrics as they're in front of you, that our precision was 0.617, our recall was pretty high on 0.778, and our FPR is false positive rate. Essentially, at the rate at which we are identifying those people as being people who will churn out, but they won't actually churn out, right? So that is a false positive, which is decently low. And the final F2 score for this specific test set was 0.7339. 0.739. To the next slide, we actually we actually wanted to bring these numbers to light because they helped us inform what is actually valuable. How is this model actually going to bring value to a hotel customer? So like we talked about in a couple of slides ago, that we ran simulations on industry standard data to see if recall was more important. From that statistic, we found out that, okay, we basically make an 8% more profit on revenue if we retain a specific customer. So that's something that is mentioned here in the third bullet point in assumptions. We also assume the final simulation that we ran, we assume that, let's say, for example, a hotel has 5,000 bookings to work with in a year. Given the recall and false positive rates that we saw above, our simulations told us that if we are able to find that the probability of a customer being retained, if they were if they're going to churn out, if the probability of them staying back is 62.15%, we will always make money given our recall and false positive rate. So that became our benchmark that we had to cross. But this is a metric that only can be calculated after the fact when the campaign is running. So this became our, this is where we actually bring value. But the idea that we have is, and something that we have seen in the industry as well, controlling the false positive rate, as in misidentifying people as who are going to churn, can be squished down considerably if we involve human qualitative interaction between the person who is on the hotel side connecting to the people who are going to cancel and see, okay, are you going to cancel or not? That helps bring down the false positives and essentially creates a great campaign for the hotels. With that, we'd like to thank you for listening to our talk. Have a great one.
Thank you.